Hello and welcome once again to episode 71 of Code Completion. We're a group of iOS developers and educators hoping to share what we love most about development, Apple technology, and completing your code. My name is Dimitri and I'll be your host once again for this episode, and I'm joined today by my fellow completionist, Spencer.
Hey there.
So last week we took a deep dive into what SwiftUI is and how to organize data for it, but we left out one very important thing, the layout system. Yay!
The whole thing.
The rest of SwiftUI. Step 1, draw the circle. Step 2, draw the rest of the owl.
Yeah.
So let's learn about the rest of the owl, which is named SwiftUI. How does the layout system work, Since?
Yeah, well, I think you went into pretty good depth on, it's not this thing that's actually Swift, but it kind of has its own, syntax and everything. So the layout is kind of like we talked about, like this recipe where we say, okay, I want a text field here and I want some labels and I want this all to be in a box that has a border or whatever. And so we'll kind of run through, I guess, the pieces of those things. And I think one thing that was interesting for me is there are basically, counterparts that from UIKit in SwiftUI, for example, a UI text field has a text field or whatever. But kind of the crucial thing that is missing from SwiftUI as opposed to UIKit is constraints, like we talked about last time, right? So I think the biggest thing is like when you make a SwiftUI view, what it's asking you to do is it's got that body computed property that we talked about last episode. And what it's asking for is a single view, right? Just one. And so the way to get around, well, okay, I need to have, let's do one of Dimitri's screens, sort of like an entire view controller. You need more than one view. And so what you end up doing is you put the more views in what is called a stack. So you've got HStacks, horizontal stacks, VStacks, vertical, and ZStacks, which are kind of a depth stack. So those would be kind of the, I guess, building blocks of like, okay, well, I have this one view or I have this body that it wants me to return a single view, but within that single view of like an HStack, VStack, ZStack, those are kind of the most common views to add multiple sort of, I guess you could think of them as subviews in a way, to that body, if that makes sense.
Yeah,
so those arrange them as you please. Sorry.
Yeah, those are the primitives that you get to work with, and I think that's where like most people either find SwiftUI to be exceptionally simple or too simple in a way. Like they're like, well, if I don't have constraints and I only have these three primitives, how am I supposed to do anything? Like SwiftUI is broken, I'm not going to be able to use it, and they then continue using UIKit. And although they are useful primitives to get like the majority of work done, they're not the only ones, right? They're just there as like the most basic basic building blocks. And in the end, they don't actually render to a real view, like a UI view that you would get to UIKit. So as you said, like you have text fields, which directly correspond to UI text field. Like it's putting a UI text field on the screen when you use a SwiftUI text field. But it's not actually rendering a view for your stack, unlike a UI stack view. So SwiftUI just uses this as pure layout information. And it decides where to put your leaf views, if you want to use like fancy terminology. Basically, the actual components, it uses these stacks to determine where they are and where they should be positioned. So it's a very different way of like thinking about it from UIKit. Like a stack is an actual object that's like on the screen, and you can't have something that like extends outside of a stack. Whereas with SwiftUI, like if you have a view that kind of extends outside via an offset or via positioning that you manually do or negative padding, what have you, that view exists outside of the stack. It's interactive outside of the stack, and that's something that you just don't get with UIKit. So that's a pretty neat thing that you get for free out of the SwiftUI layout system, because it is a layout system, as we said last time.
Yeah. Okay. My experience is limited in this area, but it seems more like kind of what you do with like HTML and CSS than it is like with constraints, if that makes sense. It's a little bit more, I don't want to call it fluid, but it's less rigid than layout constraints are, where it's like you are, constraining this view to this view. It's very much kind of like a here's what I want, make it fit type of thing. And with like you said, it's like it can kind of go outside of the range of those, or the bounds of the stacks, in a sense, where that's not really possible in UIKit.
Yeah, or at least again, anything's possible, but it's not possible without overriding especially the view itself, and then remanaging hit tests, so that way it can go ahead and gobble things that are outside of its bounds, and so on and so forth. So yeah, there's a lot of extra work you need to do to get that working in UIKit. In fact, if you have like a UI hosting controller, you can't really extend outside of that magical box. It really is like self-contained. But if you stay within SwiftUI land, then you do have quite a few options at your disposal in terms of positioning and laying out things.
Okay, so yeah, and that was something that was weird for me. Again, coming from something so rigid, is how do I align things, or say maybe I have just kind of the bounding box of a normal iPhone screen, just kind of this vertical rectangle. How do I put something in the bottom right corner? Maybe like I don't know, like a tweet button or something, like a little circle button or whatever, right? How do I do that, because there aren't constraints to say, hey, like pin this in, on the bottom and trailing edge.
Yeah, and the stacks actually get you this out of the box. Like HStack, VStack, and ZStack, they all have an alignment property, which you can change from the default, which is basically like center align the perpendicular axis. So for HStacks, that would be center aligned vertically. For VStacks, it would be center aligned horizontally. And ZStacks would just center it within the ZStack itself, but you can go ahead and say, hey, I want my ZStack to center everything according to the bottom leading edge. And then everything is going to be positioned according to the bottom leading edge of those entries. So you can go ahead and position everything that way within the stack. You can nest the stack, so you can have one that's leading and one that's trailing, and get really creative with how you kind of position stuff. There's also a spacing parameter in all of these stacks, and it's very much a magical spacing that tries to do the best thing depending on like the views that it encounters. I always set it to 0 because I don't like magical spacing. Yeah. It usually doesn't. You don't usually notice it until it's doing something slightly wrong, and then you're like trying to combat it, and then you change the order of your views, and then it's however you try to combat it just is not working anymore. So for spacing, I usually set it to an explicit 0 for my H and V stacks, and then I will use padding liberally all over the place. Because padding is a great way of like manually specifying how you want to position things. And it's a great way of determining like along individual axes, like how you want stuff to interact. So for instance, along many of my views, you can give padding and then like specify edge insets, and that's like an okay way of doing it. But oftentimes you just want the same horizontal padding on both sides. You can do padding dot horizontal 20 points. And then you also want some vertical padding. So on the next line, you just say dot padding dot vertical, and then you give it 10 points. Or sometimes you just want it on the bottom edge. So dot padding dot bottom 10 points, and then you only have it on the bottom edge. So you can specify as many paddings as you want in a way. And what it's actually doing under the hood is making a brand new container view with that padding. And all of that distills away once you actually render it out. Again, you're not making real UI views. You're just supplying layout information. So you can do quite a bit with padding, like in general.
Yeah, it's pretty cool. Like for example, just kind of the convenience methods for padding, where you don't have to supply all of the insets. You can supply .all or actually you don't even need .all if you're doing all of them. Yeah. But anyway, that's my point. Is it makes it sort of convenient if you really only care about putting a bottom spacing on something or whatever. And with that, did we talk about modifiers in the last episode?
I don't believe so. So do you want to give a quick rundown of what they are?
Yeah, so a modifier is, for example, this padding is kind of this, I guess you could, and Dimitri can definitely correct me here because I've very rarely made my own modifiers, but I think it's really just a function that takes in the view and some other information and performs some transformation and then returns the new instance of that container view that Dimitri said. Is that more or less right?
Yeah, so there's two kinds of modifiers. There's lightweight modifiers and there's more extensive modifiers. The lightweight ones are basically just an extension on view, which everything conforms to. And you can here just say self, that's the view that you were like operating on, and just stack on a whole bunch of other modifiers. So you're not really like keeping any state, you're just kind of going and simplifying code that you would have boilerplatey a little bit everywhere in that sense. The more extensive modifier is interesting because it's not quite a view, but it does still have the concept of a body and the concept of state. So it can go ahead and without needing to like make a view with a closure and all that, it already has that built in. So you just need to worry about adding extra functionality that you need to add. Maybe you need to compute some sizing, for instance. So you can have that be in the modifier depending on variables that are passed in, and it can go ahead and keep track of that state for you. And then you will end up eventually making an extension on view to call your modifier in with some nicer syntax. So it's not just dot modifier and then you pass in a constructor for your modifier. But that is a neat thing about the modifiers is you can store state along with them, which the lightweight ones, which is just an extension, you cannot. So that's the big difference. But the lightweight ones, you can still pass in information and then divide or multiply or do whatever you need to do to distribute it amongst other modifiers. But at the end of the day, it's just creating a new view, a wrapper view around whatever you call dot on. Like from SwiftUI's point of view, these are cheap things, so it can go ahead and make as many of these as it needs.
Right, yeah, and when you say make a new view, and I also said make a new view, it's again just supplying that layout information. It's not like you are actually initializing a new view and kind of creating something more extremely heavy like an entire new view would be. Cool. That's, yeah. So I just, for me, this last couple of weeks when I've been working in SwiftUI, if you just go into the documentation and look at view, just the protocol itself, it'll show you all of the built-in modifiers, and of course, it's everything about the protocol itself. But there's a lot there. We only talked about like padding and offset, but there's tons that you can do, changing the color. Definitely, well, a lot of accessibility things. I don't know, making toolbar items, help items. I mean, there's a ton there. So if you're wondering about how to do something like change something about a view, it's probably in a modifier is going to be my guess. If it's not a part of some initializer setup, like Dimitri said with the like the stack spacing or something, or alignment or something like that.
And it's easy to forget, but the canvas is interactive. So you can go ahead and use the library for the canvas to browse these modifiers that are kind of available to you, and you can drag them into your code, and you can go ahead, like there's a shortcut that you can do in your code, and you get like a little palette of all the modifiers that you can go ahead and use that is not code necessarily. Like it's just saying, hey, this one does this one does that. There's little icons, and that's a great way of kind of exploring what's available to you as well, if you aren't like super familiar with all of them yet. The documentation is kind of a mess because these are generic towards anything.
Right.
So it's like there's not a good place to just put them, which is unfortunate. And it's kind of a new problem which we haven't really ever had. It's not like Vue is a superclass. It's like, no, any view has these modifiers, but any view can have a slightly different version of this modifier. And you'll see that described in the Swift interface if you kind of command click and you get lucky enough where Xcode generates it fast enough to actually show you the thing. Otherwise, it just puts you at the top of the file and then you're totally lost. But there is quite a lot you can do with the built-in modifiers. So you probably won't find yourself needing to make your own until you get really comfortable with what is there and you really want to change some built-in behavior to do something very different.
Yeah. And when you said that, I had honestly completely forgot about like the object library or modifier library and interacting with the SwiftUI visually. I just write the code. I completely forgot that that's even a thing that you do. So yeah, it's nice. I personally never use it really. So, but it's nice to be able to drag and drop. I think that's probably a really nice thing, especially kind of getting into it and seeing how, it'll put it in the right place, assuming you drop the whatever the view or the modifier is, and you can kind of see that instant code feedback, which is cool. So,
and we didn't really talk about it too much, but it's probably a good point to mention how the layout system works. So, unlike with constraints where every view has kind of an intrinsic content size, and then you kind of build up from there, and then you have to satisfy a complex algorithmic constraint system that just like it either works or it doesn't, and then spews tons of errors in your logs, as I'm sure everyone has kind of seen before. There's no app that's immune to this, because even if you do all your constraints right, Apple won't. So you're always going to get those logs, no matter what you do. So SwiftUI works very differently in that the topmost parent kind of tells the next view down, hey, there's this amount of space. How much do you want? And then that view can go ahead and use that information to ask its own view, its own child views, hey, there's this amount of space. How much do you want? And then the child view can say, I only need this much space. So then the view itself will be like, okay, I only need that much space too. So it'll kind of go from the top down and then back up and bubble that information that way. And that's how the stacks work as well. So oftentimes you end up with situations where like you're not too sure what the layout system is going to do. Always try to remember that SwiftUI is all about proposing a size and then deciding how much space your view actually wants, and then the size of the parent will match that. So that's how it kind of calculates everything. And this is something that comes up a lot when you're dealing with things that are not just HStacks and VStacks, but also ZStacks, where you might think, oh, ZStack is just to layer stuff on top of each other, like if you have a stack of cards. And although you can do it that way, that's not really where the power of ZStacks lie. Think of it more of you just have views that would have typically been child views in like UIKit, where you have a background and then you have a scroll view on top. That is fundamentally just a ZStack, where you have a color and then your scroll view. And however big one of those views needs to be, say the scroll view says, hey, I want to be 400 by 400 points, then the color is going to try to be as big as that. Or vice versa. The color might say, hey, I'll use all available space that you give me. So it tries to be as big as possible. And then the scroll view is saying, hey, I want 400 by 400, but if you have all the space available, I'll go ahead and take it, and it'll be even bigger. So you can do some pretty neat shenanigans with like ZStack and Color.clear to make the ZStack as big as possible and kind of take up as much space as possible. And then anything in your ZStack will react to that, so you can have your HStack or your VStack inside of there, and then that can be taking up as much space as you need it. Yeah.
That's something that I've done. Okay, so for example, there was a bug that we found, or I think actually a user found, in that number pad that I was making like 6 or 7 months ago or whatever. I did that in SwiftUI, and what they are buttons, and of course inside of a button you just sort of, it just has a closure and it says, hey, give me some view to kind of make as the interactable
The
part of the
contents.
button. The contents, yeah. And what I ended up doing was, doing something like that where I had a background and everything. But what ended up happening, and it had, I think, text that just said enter on it, and it was only that enter button. And what ended up happening was I had a ZStack that it made it so that, I don't know if it was all the time, but at least with an Apple Pencil specifically, only the text itself was tappable instead of the entire kind of frame of the button with, a little bit more padding and everything. And something that I've done is, and maybe a better way to do this, but I've just made a color that is almost clear. And it seems like clear doesn't quite recognize taps from what I've seen. So I had to do like, whatever color and then opacity of like 0.001 or something, just to make it like trick the layout engine to say like this is tappable or something. I don't know if you've experienced that before, but yeah, kind of weird.
That's terrifying because there's a much better way. There's
Okay.
content shape. There's content shape, which will go ahead and, I think it's called content shape. It's called content something. I know that. That's a thing. As you gain more and more experience with development, you end up remembering less and less, like off the top of your finger, like what something is called, but you know what the autocomplete will give you.
Right, exactly.
That's gonna be just enough for the autocomplete to kick in, and then I'll be like, that's the one. And then that day Xcode autocomplete doesn't work, then you're very, very sad because you're like, I don't know what I'm doing anymore.
Yeah, hey man, that's what makes the M1 Max so worth it, is that if autocomplete is even just that much more reliable, then it's worth it to me.
Apple, sponsor our show.
Give us a new Mac Pro, please.
Yes, soon. But yeah, so you can use content shape, which will go ahead. It's like made for this if you read the documentation. If it is called content shape, I don't know. I'm going to look it up after the show. But that's one option. The second option, which I kind of love to do, is to kind of use padding against what it's supposed to be used for. So think of it this way: you have a tiny piece of text, right, and you want that to be your button. So you add some padding around it, let's say 20 points on every side. Now you have your text, which is really tiny, and then you have 20 points on every side, so you have a comfortably shaped button. But now your button is like massive, right? And it might, like, if you need more than one button next to each other or a button next to some text, now you're going to have some obnoxious padding. So what you do outside the button is you say negative padding by the same amount. So what you do is you change the layout shape of the button to be just the size that you need it to be, but the contents of the button is very large. And if you remember what I said about previously, where you can have views like escape their boundaries and they'll still like be interactive, that works in this case as well. So the button is going to be fully interactive where its contents lie. So even though you have that negative padding that kind of makes it bigger, and even though the padding is transparent, that's still interactive. Mm-hmm. So the button can be like tapped with a very comfortable touch area, but the layout area will be much smaller. So to reiterate, inside your button you put positive padding to make it bigger, and outside of your button you put a negative padding to make it smaller by the same amount. And you end up with what you had without the padding in terms of layout, but in terms of tap area, you have something very comfortable. And you can be asymmetric about this. So you can go ahead and say, put a bunch of extra padding on the trailing edge, but not the leading edge. If your button is like on the leading side or the left side of the screen, that way, even though there's not any more room off screen, you can have more room towards the right where a finger will be able to comfortably tap.
Okay, so I mean, visually, there's no change. You're just increasing sort of the, I guess, hitbox of the view itself. Yeah. Okay. Question. Maybe this isn't worth getting into, and we can kind of cut this out if you want. But with that, like, I think my whole thing was, along with that, would be if I add a set padding, I think what I was trying to do with that was make it so it would kind of fit in any place that I put it. So then if I don't want to give it like a set amount of padding, or it's like 20 points or whatever, then what do I do?
Yeah, so
Does that make sense?
that 20 points is purely for the tap area. It's not for the layout. So outside of the button, you can
Right.
give additional layout padding, or just put it in an HStack or VStack, and it'll kind of lay out with everything else. So
Okay.
it's really up to your creative decision if you want this to be horizontal or if you want it to be vertical. Typically, you want it to be vertical because things are wide horizontally, especially text. But things like text are short vertically, so you do want to be able to position them a little bit more. Not position them, but give them a little bit more breathing room for our fat, chubby sausage fingers to be able to hit in one go.
Gotcha. Okay. This is maybe a good transition into our next kind of part, which is talking about GeometryReader. And my follow-up was going to be, well, I could probably use GeometryReader to get the exact amount of size, but Dimitri has a warning about GeometryReader. So
Yeah, GeometryReader. There be dragons. So the biggest problem with GeometryReader is it can take up as much room as it needs, just like any other view. But if you don't need all that room, then you lose the ability to constrain it in any way from that point. So although you can, like, the best use of GeometryReader, I would say, is to stick one at like a very high level, and then bubble down that information via environment, like objects and stuff like that, or environment properties that you define yourself, environment values, that's the word. That's probably the best way to go about using GeometryReader, because then you can get some high level information about like what device you're on, how much room do you have for your whole screen, those kinds of things. But if you're making a small little component, you don't really want to use GeometryReader for that, because again, you lose the layout ability that SwiftUI gives you for free, which allows your view to just kind of be as big as it needs to be. This is especially obvious in things like scroll views, where if you just have like a VStack and then you have individual parts that you want to be interactive for whatever reason, so you make those geometry readers will be able to tell, like, hey, my position in the scroll view is this, but I have no height anymore. So you cannot like implicitly size anything anymore, and you have to manually specify heights all over the place. And that kind of, it's like a fighting, you can't make anything generic at that point. You have to make everything super specific. You have to decide, oh, this view is going to be 400 points because it has to be 400 points, and this other one has to be 200 points. And it's a bit unfortunate that you kind of get stuck with that whenever you do want to use a geometry reader. But and if you do want to use geometry reader, they're really neat because they do give you like exact sizing of like how much the parent gave you, because the geometry reader is like, hey, the parent is giving us this, like decide what do you want to do. But at that point, it might be tempting, hey, we can use like a preference key or something. I've never used those before, but this seems perfect. We can bubble information back up. And then you suddenly start getting logs that say, hey, you can't send a preference key more than once per frame, and you're doing it wrong. And then you're like very disappointed because you thought, hey, a geometry reader, I just wanted my buttons to be the same size. So I divided by 2, and now everything is chaotic and not working. And I'm sad. And geometry reader's stupid, and I just want to go back to UIKit now. That's like a very tempting like thought stream that I'm sure many people have gone through, and some have given up SwiftUI entirely because of that. But if you can get your job done without geometry reader, or if you're only using geometry reader at like the highest level where you do not care about using less room than every amount of room that is available to you, then like it's a totally fine tool to go ahead and use in those situations.
Cool. Lesson learned. We kind of had an earlier, I guess, conversation in our Slack group about Geometry Reader, and I've definitely intentionally steered away from using them kind of in this current work that I'm doing. And I think like that, along with like the color thing, like I know that I shouldn't have to do like 0.001 opacity. That feels wrong. And so I think like the lessons that I'm learning as I'm kind of learning more about SwiftUI is like it's fairly mature to the point where if you're doing something that you feel is weird, there's probably a better way, is kind of the vibe I'm getting. So
yeah, and to be clear, like there's a ton of this in UIKit as well. Like for instance, if you want to have a paging scroll view and you want to control how much space is in between the items, guess what? You have to make your scroll view wider or shorter than the screen, and that's the only way to do it. And you can choose to use the newer delegate methods, but if you're doing this before those delegate methods existed, then tough luck. And if you want the exact physics of paging, and you're trying to imitate that with the delegate methods, then tough luck because they're different. So like there are these trade-offs with both of these frameworks, and it really comes down to how comfortable are you with each of them. And it's really tempting when you're really comfortable with one of them to not struggle in the other one, because it's by struggling that you're going to either find a way around the roadblock or just think of a different solution. Whereas if you already know the answer in the other framework, then you're going to be like, forget this, I don't have time for this. And then you just go and do it the way you're used to. And that is something that I feel that we as people that got used to like programming via UIKit, it's a very hard thing to just accept that we are not going to instantly be good at the new thing. And therefore we don't give it the chance that it deserves, that we would have given it if we were learning the new thing first, if that makes any sense.
Oh, totally. Yeah. I mean, it took me until 6 or so months ago to really try to use it in any kind of way other than just as a toy app, throwing some SwiftUI in a toy app to kind of see what's there. I mean, you definitely get used to UIKit, and I've been doing it, the least amount out of anyone in the code completionist. So it's like, I can definitely tell that, even with me, old habits die hard, and you just kind of want to stick with what you know, which makes sense. But at the same time, it's like, maybe not to the same degree, but maybe it is. I don't know. The same sort of transition from Objective-C to Swift. Like it's kind of, that's the way it's going. And between the last, couple updates, or update or maybe two, I don't know. I haven't been following SwiftUI that much, but the last couple of things that they've done with SwiftUI to add like lazy stacks and all that, and it kind of increased the amount of, I guess, feasibility that you could really effectively write most of an app with SwiftUI, kind of makes it seem like, yeah, they're, Apple's in on, or not in on it. Like they're all in on it, right? They're going to continue to make it better. And so it just seems like UIKit and I guess by extension, AppKit are probably going to go the way of the dodo. I don't know how long it would take, but it's been a fairly pleasant experience, all things considered, for my lack of experience with SwiftUI this last little bit, to see what you can do with it. So,
and like a few more examples, because I think that was very interesting what you brought up. Going from Objective-C to Swift, for instance, a super common thing in Objective-C is everything is an object, right? So right, if you have a bunch of objects that you're going to have in an array, you'll like have a common protocol or something. That is probably the wrongest pattern you can apply to Swift, right? If you have an array of protocols, then it will work just like it will work in Objective-C, but you'll like have all over the place. You'll have if this as my type, because like you need to unwrap those types as you get to them, and sometimes the protocol doesn't like establish everything you need to do with them, and then you have typecasting all over the place, and else blocks with like fatal error conditions just to make sure you didn't miss anything. And Swift actually provides a much better tool for this, which is enums, with associated values. So you can have a main enum type, which would have been your protocol, and then individual cases for all the types that you're going to run into. You're not making a system that other people are going to use. You're making something for your app, so you can define all the cases. And guess what? If you add a new case, now the compiler is helping you by telling you, hey, you got to account for this case in all these different places where you use switch statements. And that's the reason why you should never use default in a switch statement, because you want to be able to catch the scenarios that you're not like caring for at the moment, so that way when you add them in the future, it just helps you. It's holding your hand through that entire process. So just as Swift provides very different ways of thinking about problems than Objective-C did, SwiftUI is providing very different solutions that UIKit doesn't really ever account for. And the new difficulties that come with this are something that you need to change your mental model about, or you're not going to be able to succeed as well. And changing your mental model just means living with it for a little bit and not giving up, because it will click, just like programming eventually clicked the first time any of us were learning it. It's like, if you think about it, it's a bunch of mumbo jumbo. No one understands any of like what code looks like the first time you look at it. In fact, I would garner to say that most coders don't know how to read code. Like, we know how to write code just fine, but just like speaking and reading are two different things that you need to nurture in your own life to be able to be good at them. Reading code is not something that most coders are good at from day one. Like, you can learn how to write some super simple code or apps and get better and better at that, but unless you like force yourself to read other people's code, you're never going to kind of improve at that either, right?
Yeah, for sure. I mean, that was something I definitely had to learn coming into this job with an existing code base of like, okay, I can go and make a new feature or whatever completely alone, but then integrating it into my own or into the rest of the app, or more accurately, I suppose, fixing bugs is where, most of the time you're probably looking at someone else's code. Well, yeah, in the app I'm working on, it's so large that
even
most
past
of the code
you is someone else's code.
That's true.
Than,
that's
like,
true.
3 months go by, right? It's
yeah,
really intimidating.
For sure. It is. It's very intimidating, and I mean, I have spent like hours sometimes trying to even run through what is going on for maybe like a one-line fix, but I have to understand the problem, and so that's huge, and I definitely agree with you. Going back to I guess now feels like a really good time to learn SwiftUI, because again it's pretty, I guess, mature in the sense that a lot of it is functional, but also there's not only just documentation for it, but many like Paul Hudson has a bunch of articles and stuff on it. And I remember when I again, back to, sorry, this is becoming a theme here, but back to WWDC 19, the week, and I think probably about the month or so after that, if you Googled SwiftUI, Google would say, "Did you mean Swift?" Because there was literally nothing. So we're at the point now where there are resources for you to learn.
Yeah, and
people have done stuff.
And as you mentioned, like, if you need help with SwiftUI, if the first, second, or third link in Google is Hacking with Swift by Paul Hudson, click it. That is the solution to the problem you have.
Yeah.
They are so bite-sized and so easy to understand and to be like, oh, that's what I'm doing wrong and that's how to correctly approach it. That really, like, that should have been Apple's documentation, but it unfortunately isn't. But fortunately for Paul Hudson, he can now claim the top spot on Google because he has such perfect bite-sized pieces of knowledge that solve like very specific problems with SwiftUI that are not really problems, because once you see the solution, it's like, oh, that's very straightforward how to go about and do that. It's not like a mumbled jest. I'm forgetting how to speak. It's not a mumbled mess. That's the word I was trying to say.
Jumbled mess is probably what you're going for.
Jumbled mess. Oh gosh, I'm having a stroke live on a podcast. So joking aside, strokes are no fun. That is something that is really an invaluable resource that I hope everyone can like spot when you do need help. Is do look for hacking with Swift links, because they will, or not just hacking with Swift links. Swift by Sandel links are also great. Avoid Medium links. I'm sorry, anyone who writes anything serious on Medium. It takes forever to load, and you have to like scroll for ages past a bunch of memes and stuff, and it's not helpful. So sorry. I don't want it to be that way, but it's not useful for we need a solution at this point in time.
Yeah. Well, I think that's one of the best parts about hacking with Swift is everything is so concise. And there were a couple that I looked up just the other day this week where it was maybe 2 paragraphs, if that, and a snippet of code. And that's all I needed for whatever the SwiftUI problem was. It wasn't this entire 10-minute length article, So, and sometimes that's all you need. Sometimes you do need something more in depth, but for, like Dimitri's saying, these very kind of specific SwiftUI problems, a lot of the time they are super concise, and that's kind of what you want. And it's coming from a reputable source as well. Yeah.
And I've said in the past, like especially on the show, I believe, if you do want to search through past episodes, that I felt like SwiftUI was missing like fundamental primitives to build your own stuff in it. And that was like the core thing that it was lacking. And 3 years later, we still didn't have that. And I was like disappointed. That was a naive like sentiment, I would say nowadays, because like coming from me directly, it's possible to rebuild something as complex as collection views entirely in SwiftUI. This is something I've done for a private project, and the only piece of UI kit that I touched was rewrapping scroll view to be slightly different. Like it was maybe 60 lines of a UI view representable, just because I needed the ability to get the scroll position more reliably than using a geometry reader. Again, geometry reader evil. But doing it myself like gave me all the pieces I need to, one, do lazy view loading such that I don't need to actually build out views for all the cells that come before or after. I can just do that mathematically and give a Color.clear a frame, and that Color.clear is now how big my scroll area is. Then I can do a separate pass to determine, okay, which views are on screen. And once I collect that information, I have an array of model objects that are on screen, and I can pass that to ForEach, which will just draw those objects. And then finally, you might wonder, well, how do you position all of this? Well, you have offset and you have frame. Frame gives you the size, and offset gives you the position. If you have a ZStack, which is top left aligned, then you have the usual coordinate system that you're used to from that point forward. And as a bonus, it works on macOS and iOS the same exact way. No coordinate system flipping. Like, this is something I built. It works with iOS 13's era of SwiftUI. Like, we could have done this from day one, but none of us had the experience and the different model of thinking that was necessary back then. But none of the new stuff kind of enabled any of this. The only thing that I had to finagle was a state object, because I still need iOS 13 support. So I finagled that with an observed object and a state, carrying the same thing. So like all the building blocks were there. It's just unfortunate that there was no like in-depth examples coming directly from Apple, probably because they didn't really know like fully what something was capable of. It really reminds me of console generations, where the first games that come out for the console are like super basic. Not nowadays, I would say, but back in the day, like Nintendo 64, first games that came out, not the greatest in terms of 3D capabilities. Then you have Ocarina of Time that came out 6 years later, and it has all the bells and whistles that, like, how were they able to do all of this on the same console, you might wonder. Well, it's because they had more experience with it. They lived with it a little longer. They knew all the tips and tricks. They invented tips and tricks along the way, and even though the hardware didn't change, they were able to get more out of it, right? That same kind of mentality exists for the frameworks that we use, especially new paradigm shifts like SwiftUI.
That's an interesting way of thinking about it for sure. Just kind of having that specific domain knowledge and knowing, I don't know about pushing the limits, but knowing the true capabilities of something.
Mm-hmm.
That's super cool.
Yeah, so I guess we can run through a bunch of like the other little notes I have here of like useful tips and tricks, because that's what this is all about, is sharing that. We can't just like tease you and say, hey, it's possible to do the super complex thing. Just don't give up, and then see you next week, everyone. So with that in mind, like, here are some things that are super useful that you might not necessarily know about. The first one is FixedSize, and FixedSize is a bit confusing in terms of like what it actually does. But if you think about it, it's really about not accepting the proposed size from the parent that's coming down and just saying, no, I actually want a specific size, and I want my size, and I want that to be the size that I'm going to be. And then the parent has to force to adapt, whether it centers you or it will grow around you. That's something else. But this is especially useful with things like text, where you might notice if you don't use FixedSize with text, sometimes you get your text laying out, sometimes it just has a ... on it, because the text is always going to try to just use the available space that the parent is giving it. However, if you use FixedSize, you can go ahead and say, hey, the width, it can be flexible, but the height, I want that to be fixed. So at this point, the text is going to always take up as much room as it needs in terms of height, and then bubble that upwards when the views kind of resolve their layout. And that will oftentimes fix a lot of issues you have with flowing long lines of text. So anytime you have text, always give it a fixed size, and that will kind of help you out. Another situation to use FixedSize is with ZStacks. And that's for similar reasons. ZStacks have many different views that are inside of them. So you can ask it to be exactly the size that it wants to be, rather than take up all the amount of room or not enough of the room. So do look at that if you are kind of running into any issues.
Yeah, FixedSize has been interesting, and I ran into, I can't remember if it was this week or last week, where I did have to use it for text for sure. And I think, like Dimitri said, a cool part about that is you can specify, do you want a fixed size on both vertically and horizontally, or on just one? So it is pretty flexible in that way. Interesting about not GeometryReader, about ZStacks. So I guess if you wanted it to not take up like the entire view's size, but you just said, I want it to be 400 by 400, it would do that? Or maybe I didn't quite understand what you meant about the implementation with the ZStacks.
Yeah, so it's all about creating a counter proposal to the size that the parent is kind of asking of you. So if you do the trick where I said previously, where you have like a Color.clear inside the VStack to kind of make it maximally take up all the amount of room, you can go ahead and use this to tweak it in just the right way, where it might have ended up too small for the contents that are in it, and then the contents ended up shrinking themselves to accommodate for that space. Okay. So this will go ahead and tell it, hey, don't shrink past that point where you feel like you are now being constrained. You can think of it like the hugging priorities and auto layout, even though it's kind of different, but it is in a similar vein to those.
Okay. So, with that, and this is something also with modifiers is, and maybe not with all, so this is my question here. For example, if you give a VStack a foreground color of white, that propagates down through all of its subviews, right?
Yep.
So does that happen for everything, including fixed size, and that's why all of the subviews will take up as much space as they need?
No.
Does that make sense?
So yeah, you can think of modifiers as like some of them are environment values and others are like proper container views. I would say the foreground color is an environment value kind of modifier. And this is still an area where I'm a bit disappointed by Apple's API decisions. I think it would have been a lot more useful for them to make all of those environment values that those modifiers like touch publicly accessible. And some of them are, but not all of them are. One such instance is like, hey, if you want to do your own containment with dismiss, that won't work. You cannot use dismiss with your own presentations. You can only use it with the provided presentations. Where like I could have imagined a scenario where there's a modifier to pass in your own dismiss handler, and then any child that calls it will kind of bubble up to your modifier, because that's what's happening under the hood via preference keys and environment objects, or environment values, I should say. It's just not being propagated publicly via the keys that are provided. So that's one class of modifiers. And then the other class of modifiers like FixedSize or frame, or padding, they're very much just wrapping the view in another view with some slight layout modifications.
Okay, yeah, that makes... Oh yeah, now that you say like padding and everything, that makes total sense. That of course that doesn't propagate down to all the subviews.
Yeah, all of a sudden, like everything would have. It's like saying, what's the shortcut in HTML and CSS for that? It's like star, and then you just put padding, and then all of a sudden everything has padding.
Right,
yeah. So that's not what padding does.
Okay.
So there are a lot of similarities with the layout systems that web developers are used to, but then there are a lot of like course corrections, I would like to call them, where they decided. Yeah, that wasn't the best decision to kind of have it be that flexible. So we're going to have a more opinionated stance for SwiftUI.
Sure.
And therefore, yeah, you can't do super complicated, crazy things like you can in CSS. But things are a bit more, what's the word, where they're more consistent and like easier to arrive at a mental, like the human can follow the process as much as the computer can, if that makes any sense.
Oh, totally. There's some crazy stuff on like CodePen of what people have done with just HTML and CSS, and you're like, how do they even conceive of this, let alone implement it? That's
again,
cool.
anyone can learn to write code quite easily. It's the reading code that becomes like very hard. You can try to read it and you still won't really understand like how they came to that conclusion when they were writing it. They're like tweaking along the way. They're like, oh, what happens if I do this over here? Oh, I get that result. And any code that ends up as a result of that tends to be tremendously hard to read, because it's not calculated at authoring time, right? Of how like no one made an outline first before they started writing it. It just happens that way because that was the only way to make it happen, right? You need to iterate and adjust it. And the same goes for code. Like if you just iterate and adjust it, you're going to end up with something that's very hard to read unless you go in and refactor it before you forget how it all works in your own mental model. So if you can do some architecturing and outlining and planning ahead of time, generally you have a more robust system that's going to be with fewer bugs, because it's going to be better documented and it's going to be more clear of how and what it's actually doing.
That's fair.
So another one of these useful modifiers is frame and offset. Like as I mentioned, you can build a collection view with these. Frame is a little neat because there are two variants of frame. There's one where you can specify like a width or height or both, or like just one of them. And this is super cool when used in combination with something like Color.clear. One of my favorite ones. If you want a ZStack that's infinitely wide, but at a specific height, or it's only as big as the text inside of it, for instance, you can have a ZStack with a Color.clear in the background, and you give that Color.clear a height of 1. I don't know if height of 0 works. I'd never tried it. It always felt like this shouldn't work, so I'll just put 1 instead. And then text on top of it, like visually in the ZStack, and then your view will be able to grow like vertically according to text, and it will always take up all the amount of space horizontally. There are better ways of doing this. I now have learned, like you can use frame with a max height or a max width or a min width. Like there's all sorts of bells and whistles you can turn, and that kind of owes itself to the complexity of SwiftUI. Is like, how do I know what any of these do? There's not like many examples, and you end up just like trying it haphazardly and seeing what sticks and what works, which is fine. But one really neat thing that came to mind recently when it comes to SwiftUI, and one of the common called out shortcomings is, hey, with UIKit, if I want two buttons that are right next to each other to be the same width, kind of like OK and cancel, and it's not anymore, but in old Mac OS, OK and cancel were like horizontally next to each other, and they'd always be the same width because it's more pleasant for them to be the same size. How do you go ahead and do that in SwiftUI and the UIKit experts would be like, oh, I see cat's got your tongue. You can't actually do that in SwiftUI, and that's actually very hard. And you could just set an equal width constraint and be done with it. And to that, I propose the following like 15 lines of code, which are the entire thing. Like, you're not setting up labels, you're not setting up stacks, you're not doing anything complicated like you would in UIKit. You just have an HStack with two texts in them. And the magic piece here is you can give them a frame with a max width of infinity. And then however big your HStack is, or however wide your HStack is, both of the child views of your stack, both of the texts basically, they both want to be as big as possible, irrespective of their contents. Oh. So if your HStack only has 250 points available to it, it's going to give half of that 250, so 125 to each of them, and they're going to be the exact same width. So that's a very convenient way of like specifying those same constraints in a different way. If you just remember that SwiftUI, the child just wants to be as big as it possibly can, and then the parent kind of sizes according to that. Well, if you have two things that are sized differently, just make them size the same, and you can use frame for that. So I'll leave a sample of that code in our show notes, so that way you can kind of see it. But oftentimes it really does just require a different way of approaching the problem, rather than kind of being stuck in the old ways of thinking that if there's not a modifier that would make that easy. Like, there's tons of pre like 2021 kind of articles saying, hey, if you want to do this, you set up your own alignment guides, and then it's like 200 lines of code later and you have two things that are sized the same. But it really can be done simply. You just need to better understand how the layout model works, right?
Okay. I know we're trying to get through this. This is all very fascinating to me. So the key with that is that you gave it in the frame, you gave it a max width instead of an actual width, or the actual width would say like make it infinity no matter what. Yeah. The max width is just saying try to make it up to infinity, but be flexible, basically. Exactly. Yeah. Okay. That's super cool.
And with that same parameter, you can specify a minimum width. And you can say that, hey, if it gets to that point, then it won't like go any further. And you can play with that endlessly to get all sorts of different behaviors that you're interested in. But like the whole point of that specific example is it's not impossible to do the things many people think are impossible in SwiftUI. You just need to really wrap your head around it differently. Similar.
That's. Oh, okay. Sorry. I was just going to say, I think that's the biggest thing is understanding the layout engine under the hood and knowing what it's doing. And I'm most definitely not there. And being able to infer when I, give it an infinity, frame, max width frame, what does it mean type of thing and all of that stuff. So I think it just, like we said, probably comes with experience, and I'm not there.
But again, the whole layout contract is very simple. Like, it's all about like the parent proposing a size, and then the child becoming that size, and then the child like iteratively doing that down the chain. So once that mental model clicks, then it becomes a lot clearer about like how everything is working. And since SwiftUI is so easy to iterate with. It's, I think, a mental model that clicks a lot faster for a lot of people than it does with UIKit and with storyboards and constraints, because all of that is very static. You see it just as a static view as a storyboard, or once you are able to materialize it in your head, you can go ahead and do it in code and skip the storyboard. But you can't really see it in movement until you run it on device and try something and be like, this broke everything. Whereas with SwiftUI, when you're using that canvas, you can very rapidly try all the options that Frame gives you and be like, nope, 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 nope. Yes, this is what I wanted.
Yeah.
And that is, I think, something that helps people get comfortable with it very, very quickly.
Yeah, that's fair. The feedback is definitely more instant.
And additionally, by this point, like we've had SwiftUI for, I don't know, 3 years now. There is a lot of prior knowledge that's been shared at this point. So we are sharing it here, but you found an excellent guide to understanding SwiftUI layout behaviors as well that will link, that just goes through like basically all the provided views and like, this is what it wants to do. So if you need a reference, like there are tons out there nowadays. Google is your friend, I would have to say in that regard. Yeah, so you have Frame. You can go ahead and offset things with .offset. .offset I tend not to use as much. I generally will like offset things with paddings because that tends to be something that affects other views as well. Whereas offset will just kind of take it and just like nudge it somewhere else on top of or underneath stuff you have no clue. So it's a little haphazard in that way. But it is available if you need to position something absolutely within your canvas. So that is always available. There are a bunch of neat views like ForEach, which have very specific semantics. So never use ForEach with like a list of indices, because then you will never get any changes, because it actually listens for changes to the array and will propagate that down to the contents. So that has a side effect that if anything in your array has the same ID, that view will only be rendered once. So if you ever have a ForEach, and as you scroll in your scroll view, you'll notice like some views disappear and then reappear. That's because those two views have the same IDs. So make sure if you do use ForEach, everything has different IDs like within it. And do know that IDs are used to track like existence for views themselves. So you can do this manually. You can just give a view an ID, and then that view will not be rebuilt in as many situations if the ID doesn't change. Or like if you're trying to animate between two views and like the sub views are animating but not the parent view, give the parent view different IDs for those different situations that you animate. And when you animate to a different ID, then the whole parent view is going to be swapped out and transitioned. So that's a useful technique there. What else do we got? There's a bunch of bridged views. So anytime you have a list, any controls, navigation view, etc., those are all bridged from UIKit. I have found myself rebuilding tab views because the bridged version is inadequate, to say the least. I tend to avoid list because you end up with the trap that it's a table view under the hood, and the same gotchas with table views exists in SwiftUI, where not all of it is configurable from SwiftUI. Navigation views equally have the same problem if you need to mess with the actual presentation of the nav bar, especially now it's 15 where it like hides it for no reason until it doesn't want to hide it, and then that might mess with all your layouts. So you need to drop down to UIKit, UI what's that called? Appearance, UI appearance, to go ahead and like customize it globally, or sneak in some code that will like introspect the view hierarchy and kind of fiddle it with it that way, which always feels kind of fragile. So I tend to prefer the UI appearance route. Don't be afraid to break out of the cage with UI view representable yourself if you do have something specific that you want. I think UI search bar or UI search field, what's it called?
UI search bar, yeah.
Yeah, that tended to be the go-to like UI view representable example because it was never provided until recently, and you still kind of need it if you want to do custom search presentation. So that's something that you still need to kind of do quite often if you do want to bridge in something that UIKit provides that SwiftUI doesn't. And SwiftUI is totally happy with you doing that. It's like a fully built-in thing to go ahead and bring in views from UIKit, even your own views. As an example of this, if you are in a completely UIKit app, you can go ahead and use SwiftUI previews to preview your controller or your view as you're building it. And all you need to do is have your little preview section have a subtype that's called container, which is UI view representable or UI view controller representable. And in make view, you just make your UIKit view. And then as you change your UIKit code, you'll see it in the canvas instantly, which is super magical because it is way better than storyboards because you get to see it live. So even if you are locked to UIKit, you can still use SwiftUI magic to kind of preview things by using UI view representable, which is pretty neat. This week's episode of Code Completion is brought to you by Sticky Widgets. Sticky Widgets is the absolute easiest way to put a sticky note on your home screen and edit it quickly. It's so easy, you never need to open the app itself. Add a sticky widget to your home screen through the iOS home screen editor and tap on it to edit. That's about it. Of course, there's tons of customization options as well. Font, color, text size, alignment, all conveniently located in the system's edit widget interface. Add as many sticky widgets as you'd like or put them in a smart stack. Sticky widgets are digital sticky notes for your phone. Use them however you like. Sticky Widgets is a free download on the App Store, and additional font color options are available for a one-time in-app purchase. Thank you so much to Sticky Widgets for sponsoring Code Completion. Check out Sticky Widgets on the iOS App Store today. And as always, I want to personally thank everyone for listening in this week. Please be sure to follow us on Twitter at Code Completion to know when new episodes get released, and feel free to tweet at us if there's ever a topic you'd like for us to dig into. Most importantly, as a small podcast, please be sure to share this with your friends and family who are also interested in any part of the process of app development. It's your support that enables us to continue doing this, and we hope to grow a healthy community around everything we discuss. Once again, I want to give my thanks to Spencer, who is at Spencer C. Curtis. That's SpencerCurtis on Twitter for joining me this week. My name once again is Dimitri. You can find me at Dimitri Buñol. That's DimitriBouniol, and we'll see you all next week.
Bye.
So, in other news, Nintendo finally fixed their N64 emulation. Fog is back.
Reflections are the way they should be.
They're reflection-y. The water temple is as horrible as it always has been.
At least it doesn't look horrible now. What a joke, though, man.
I, as a kid, never found the water temple to be, like, so reprehensible that the whole internet has kind of, like, backed as a moral high ground up until now.
The only thing I remember as a kid was I couldn't find one key, and it was like in the middle pillar thing. It took me so long to find that dang key to continue that's really the only thing that I was like very upset about with the water temple. But yeah, I don't know, man.
And that's the whole point of exploring, right? You're gonna miss stuff.
I know. But it is very famous, I suppose. Maybe more than it needs to be, but yeah, I mean, they fixed that. I think there was another one with, like, Paper Mario. I haven't played it.
Oh, yeah.
I played it as a kid.
It would crash and destroy your save data. It would just
straight up crash, dude. and it's like when one of them...
in the process.
Yeah, when you have, like, a specific partner, which you will have. So it's like, it would happen to everyone if they were to progress to a certain point, if you die.
Playtesting.
So, that's crazy. Well, let's see. Paper Mario hasn't been out that long. I think that came along just a little bit ago. But, like, Zelda has been out for, 3 or 4 months, probably?
Mm-hmm. So, yeah, it seems...
them now?
Okay, so they have been improving it with every point release, which is, like, I applaud you, Nintendo. I was expecting this to forever be broken. But they, like, did not like the first release was horrible. The input lag made everything jello-y. The fog was non-existent. Reflections were completely broken. And then the next release, the fog was still broken, but they fixed the reflections. And then the following release, they made the input lag a little bit better. And then the following release, like finally now we're at a point where it's like a 1-to-1 with the original N64. In fact, I saw a tweet that for Majora's Mask, they even added lag to the ending, because if you don't add lag to the ending, then the song finishes after the ending sequence. Like the ending sequence would just render faster. Whereas on the hardware, we're gonna add whatever we need to add, or like shorten the song to make it fit the render, because the render is just taking too long. So now with faster the computers, the emulation happens regardless of like what the hardware capabilities were. So it's perfectly capable of just like plowing through those calculations and getting the ending credit scene finished before the music, which was a problem on the Wii Virtual Console, I think. So that was pretty neat that they actually added lag back in, so that way that would end at the correct time. So
at the right time.
Yeah, it seems like they are putting effort into improving it, and bravo Nintendo. I didn't think you had it in you to actually do that.
It only took the entire internet being mad at you to do it.
Mm-hmm. But they took it seriously.
Yeah.
Like there was an era of Nintendo, like basically the GameCube era, I would say, where they did not care as much about other people's opinions, and like it seems like the GameCube was hurt because of that. And therefore they reverted, and then the Wii was something that they were able to get a bunch of developers to help build out one of the most successful platforms ever. And then they built the Wii U, and they're like, okay, we're back on our high horse, and we know what we're doing. And that didn't work so well, so then they made the Switch. So they always have this like back and forth of like, aha. There's that one like anime meme where there's like this lady in a fighter pilot cockpit of like, they know exactly what they're doing, and then all of a sudden the tables are turned and they're like, I have no idea what I'm doing. It's that all the time.
Yep. I'm still mad at Nintendo. So
are you ready to share yet, or is it gonna stew for a little longer?
No, I need to stew. I'm still I have a Nintendo story. I don't know. It's not that big of a deal.
No.
I'm probably making it out to be more of a big deal than it needs to be, but I had to buy another Switch. That's the short of it, so we'll talk about that eventually.
Well, now you have another Switch that you can load ROMs onto the emulator and play old Nintendo 64 games on your Switch.
I guess. I don't know.
No joke, I saw people doing that for the practice ROMs for speedrunning. And I was like, how did they get the practice ROM? Oh, they can just like hack their Switch. Duh. That's how they got the practice ROM. Because the practice ROM will like tell you the angles and stuff, so that way you can do all the silly memory hijinks.
That's cool. I guess that makes sense that they could just load up whatever they want on there.
Mm-hmm.
Yeah, that's cool. Is anyone like speedrunning the Switch version?
I don't think so.
Oh, okay.
I mean, the N64 version has been like completely destroyed.
Yeah.
From like,
I think
remote code off.
Arbitrary code execution.
Yeah.
Yeah.
Stale reference manipulation.
Man, it goes so in depth. Like, I know we've talked about this before, but people's dedication to figuring out how games work is insane.
Mm-hmm.
So cool.
Yeah, it really makes it fun to be a fan on the sidelines, just watching it. Because every like month or so, there's just like a new. It's not an exploit, but like a new like way they found out like how that universe works, just like science works in the real world. It's like, oh, they ran experiments, they noticed something was off, and therefore they went and discovered something new, and like bravo.
Yeah, they're decompiling the entire game and everything. It's
recompiling it with their own code, which is copyright safe, which I think is awesome because copyright law needs a fixing.
Yeah, I just saw that the unofficial PC port is like 90 or so % of the way done for Ocarina of Time. That's so cool, dude. Oh my gosh.
I can finally run it at 4K. See all those polygons on Link's face.
Oh, all 10 of them.
All 10 of them. And his box hands.
Yeah, dude. It's so good. Oh. I was watching a video of ZFG, who is a speedrunner of Ocarina of Time, and they've got like multi-world online Ocarina of Time, and they were like, it was 2 people playing in Ocarina of Time at the same time, but they didn't share they didn't share items, but you could find items for either one of you. Mm-hmm. And the thing they were testing was like, oh, you can hookshot each other. So what happens when you hookshot someone that is in the air, but they're paused, so they stay in the air, and then you can hookshot to them, and all of this stuff, and the experimentation of just like how can we break this game is awesome. It's so cool. Mm-hmm. So good stuff.
Yeah. So I think I always wonder, like, modern game developers, if they look forward to the shenanigans that speedrunners will eventually find if their game becomes popular enough, right? Like I feel like there's a certain part of you as a game author that like wants your game to be successful, like financially, so you can continue to make games. But then there's a second part of you that just wants to be successful enough to be completely broken in speedrunning challenges, just so that way you can root for them. And like, I wonder if even in these big companies like Nintendo, for instance, day one, there were some like very finagly glitches that were found for the physics engine that could have probably been fixed. But Nintendo didn't necessarily fix the ones that were not game breaking, that were just funny, or like you actually had to have skill to pull off. Like, they left those in, I would think, consciously, right? Because like they would have had to know that people were like clipping into shrines or through gates in the improper way, or catapulting themselves via tree
off of trees,
to like zoom by the landscape so fast that the whole game glitches for like
has to load for a couple seconds.
Like you just know that they realized this was happening, but
you hope so. Like, I don't know, if not, it's like, did they really even playtest this thing? Like, try to break it in weird ways that like QA people would think of? I don't know.
Well, they probably did, because like even now we're finding new ones, but it took like how many years has it been? 5 years?
It's been a while, yeah.
So like they definitely did play test it. They definitely did put a lot of quality, but like you just know that they resisted fixing a lot of issues that they could have fixed, right?
Yeah.
Like they were still developing it for a few years, like pushing updates and stuff. Like they could have fixed many of the wonky things that we do nowadays, or not we, like I don't do any of them, but speedrunners do. And pull off, right?
Yeah. I was watching a speedrun last night. I don't know why, but it popped up on YouTube, and it was of Sekiro. I don't know if you've heard of that game. It's from the same people that make Dark Souls, and Elden Ring. But it's anyway, there's kind of this one wall that you can kind of run. You gotta use all of your movement to get to this wall, but once you get through there, you clip through it and you start swimming through the air, and it basically breaks the whole game. And it's like, I wonder if the dude that like was in charge of that wall, of making that wall, and forgot to put in that I don't know, actual physics wall where it's not just a texture, if he's like, oh crap, that's my fault, or he's like, yeah, that's my fault that they're doing that. You know what I mean? So it'd be interesting.
They
to see,
hold a party for him, like the whole team.
All the speedrunners.
Like, whose code was that? Oh, it was Bob's code. Yeah, go Bob.
Yeah, pretty crazy. It's not going
to influence sales of the game.
No,
it's purely like, if you go ahead and fix it, then the speedrunning community is mad, but not that mad. They have their versions and their their stuff.
Yeah.
Like there are ways around like those kinds of limitations in terms of like when they record records and stuff. But for the most part, like, yeah, you don't ever see like any game developer who's like salty about it and like trying to like fix all those issues. Even though they're still developing the game to some capacity. So I think that's like a heartwarming side of the game industry, or at least I hope it is, and it's not just like, oh, there's no financial like support to go ahead and fix those issues, even if they wanted to. So
yeah, maybe it's just like there's no financial incentive. But I mean, I don't know. It's cool that Nintendo, like, I remember Nintendo said for Breath of the Wild, like, with one update, they're like, this is the last one. And they just did that for Smash. So, like, anything goes from then on. And, hopefully you find something cool that they either didn't care to or didn't, purposely didn't fix. So,
yeah.
Speedrunning's cool.
Definitely get into watching it if you can. I don't know like what is involved with getting into actual speedrunning. That seems like a lot of time and effort. But the community seems super chill and open to people coming in and not at all like mad about you stealing someone else's techniques or anything. Like that's the whole point. To just be the human that can perform the task. Or if you're not that human, be the human that was dedicated enough to make a task to perform the task, just to make a video. And as long as you like thank everyone who's involved and be nice to the community, like everyone is like super supportive about that. So yeah, if you want to speedrun, go speedrun so we can watch your videos. If you don't want to speedrun, go speedrun other people's speedrun videos.
Yeah, or like and. Yeah, just watch. You can find the actual like world record videos or whatever. But then there's channels on YouTube like Summoning Salt is probably the most.
Oh, they are awesome. Did you watch the Punch
Out
one
good.
That came out recently?
Yes, it was so good. But Summoning Salt will go through these like history of these speedruns, but explain how this glitch works or whatever. And it's just it's fascinating again to see how people have figured this stuff out. And there's one with like not the Punch Out one that just came in, but the original Mike Tyson's Punch Out. That's like there was this one guy you never knew when he was gonna do this one move, and then someone noticed that like the bulb flashing that Mario has on his camera in the background tells you about that move, and like people have played this game for. It's old. It's from like the 80s or something, or the early 90s.
And it's not because the developer necessarily did that, which is like the best part of these old games. It's because the random number generator was influenced by the memory that was at that address and just happened to be like the signal. And that's like the part that's like mind blowing. Yeah.
Speedrunning is good.
An excellent note to end off on.
All right. See ya.
Bye.